Welcome to Spring LIB.
Hello everyone, today we're doing chapter 19, problem 14. And this problem asks us to label the protons labeled A, B, and C in increasing acidity and explain in detail why you chose this order. So to determine if something's acidic or to determine how good an acid is at being an acid, we need to investigate the stability of its conjugate base. So how stable is the product once it loses its proton? Because that's what acids do. They give away protons to bases or nucleophiles. So for something to be acidic, the conjugate base, so the deprotonated form, must be highly stabilized. So let's start with A. So if we lose HA, that is going to leave us with a carb anion charge concentrated at this carbon here in the benzene ring. So a negative charge on carbon is not favorable, and because there's no actual conjugation outside of this benzene ring, this carb anion can't actually move anywhere. It's kind of stuck being localized on this carbon atom. So losing HA produces a conjugate base that is not that stable. So now let's look at HB. So if HB leaves, what will happen is that now you will get a conjugate base that places a full negative charge on this oxygen molecule. Now, once again, oxygen would much rather be preferred to be neutral. However, oxygen is highly electronegative, a lot more so than carbon. So because oxygen is very electronegative, it is electron loving. So it's actually happy to gain those electrons from the leaving of this proton here, and it's actually okay with gaining these two electrons and having it around its nucleus. So in terms of stability, losing HB is more favorable than losing HA because it puts a negative charge on a more electronegative atom, being oxygen, than on a less electronegative atom, being carbon. So the conjugate base of losing HB is going to be more stable than a conjugate base of losing HA. Now what about HC? So if we lose HC, so HC comes off, and I'm actually drawing the arrows back the opposite way because the electrons in the sigma bond will actually go on to the nucleus, and the base will donate the electrons needed to form the new bond with the hydrogens. So if we lose HC, what we see is that we also get a full negative charge in this oxygen atom. So just like in HB, but now here's the difference. This negative charge is not only stabilized by being on an electronegative atom, this can also be stabilized through resonance. So if we look, we can actually have a resonance structure with the carbonyl oxygen such that now the negative charge has moved on to this cardinal carbon, forming the resonance structure of this. So not only is it stabilized by having a negative charge on an electronegative atom, this is also stabilized by resonance. So stabilized by two forces. So the loss of proton HC, the conjugate base of losing HC is much more stable than losing HB and HA. Remember what we said in the beginning, in order to be the best acid, you must have the most stable conjugate base. So clearly, we know that in terms of increasing acidity, HC is going to be the most acidic proton, HA is going to be the least acidic proton, and HB will be in the middle in terms of acidity.